Guys, in a previous video I showed you how you can use the controller configuration tool to program an air handler. I will leave a link to that video up above to where you can go back and watch it. What I'm going to do in this video is actually show you one way that you can calculate your discharge air temperature of your air handler. There's many reasons why you may want to manipulate that in the system, and instead of having to change it manually, you can actually let the process, let the software do the work for you. For example, generally during the winter time, some buildings may be difficult to heat, and raising the discharge set point on your air handler may help in the heating of those buildings, just depending on the application, that sort of things. There's several ways that you can do this. You can actually use VAV heating demand. You can also use outside air temperature, and as far as which one works the best, that really depends on the particular building. No two buildings are alike, as I'm sure many of you all know. Now what we're going to do here, this is a program that we had written in our previous video. And what we want to do, the cooling output, of course, is one of the factors that plays into the discharge air temperature. I am going to right click it and I'm going to select show involvement. This shows me everything that is connected with that output. It shows me everything that's going to be involved in the process of determining the position of that actuator. The same can be said about the mixed air damper, that sort of thing. Show involvement. You're going to see some of the same ones that do play into that also. And that's just something that I wanted to show you. If you're ever curious about how something is being controlled, this is one option that you can use to determine exactly which logic blocks are affecting a particular output. What we're going for is this particular one right here, the discharge air set point determination. Here is our discharge air temperature set point that would be pulled into Metasys, and you can see here backnet exposed. That means I would be able to do an auto discover and pull it directly into the Metasys system. The default value is 55. This is just some of the standard things that we see here. You can add a description and that sort of thing, hit edit, and then just make whatever changes necessary. And we're not going to be changing anything in this right now. So I'm going to close that out, and currently if we look in here, we will see some pre-existing logic. This basically, with warm up cool down, it goes to a predetermined value, and that's it. That is one option of controlling the discharge air temperature, but depending on the way that it is going to work in your system, you may want to do something differently. So actually what I'm going to do is I'm simply going to highlight all of this. I'm just going to get rid of it. It's going to ask me if I want to delete, and yes I do, and it's going to take it a minute and it's going to go away. Now it's giving me here, it says the following invalid connection will be removed from the diagram. Connection is missing. This is an error that's going to give me. Okay, I'm simply going to hit OK on that, and it's going to then, the only thing that I have is the effective discharge air temperature set point, which that's something that we are going to use. There's a couple of values which I need to pull into here, and what we're going to do is input floating. We're actually going to do a few of these. The first one is going to be pulled in as our outside air temperature. We're going to add this and link it to the sensor for this system. So I'm going to double click it and simply call it OA-T, outside air temperature. It's very simple, very straightforward, and we're going to need a few more of these. I'm going to go back here, grab another one, pull it over, and it's going to be our second one. And it takes a minute for some of these to populate, and that is going to be affected by your particular computer. This one I am actually going to call it the Discharge Air Temp High Limit. Okay, that's something, this is going to be the maximum value that our temperature will go. There must be a limit to how high that it goes. This is all part of the way that the logic is going to do the calculations. Since we have a high, we are also going to add a low. As you can imagine, there's a minimum amount. We don't want it to simply just keep calculating down. For this particular unit, we're not going to go down below 55. So again, simply double click that and call it DAT low. It's that simple. I like naming these. It kind of makes it a little easier, especially when you come back in 2 or 3 years to make a change or to try to troubleshoot something. And it just makes things go a whole lot better, a whole lot smoother. It saves yourself a lot of aggravation. And we're still going to need a couple of additional points also. We're going to need a couple of variables that are going to be used for the calculations. So this, again, are going to be the floating inputs. And I'm going to pull them over. In fact, I'm just going to go ahead and grab another one while I'm here. I'm just going to let that one populate. Taking just a little longer than I'd hoped, but just bear with me. And just go ahead and pull both of them over, and that way it saves us all a little bit of time. And once more. Okay. It'd be nice if this would go a little bit quicker, but I'm showing you guys this in real time, so just bear with me. That way it kind of gives you a better understanding of what this does. This one, we're just going to call it variable 1. This is a variable that is for the calculation. And here we're just going to call this variable 2. I think it's going to be straightforward. You can call it whatever you need. It really just, however your logic flow is, you just call it whatever you need. Again, it's just part of the calculation for this. Very simple, very straightforward. Now that I've got my variables added in here, what we need to do now is add another block, and that is going to be a span block. And where you will find that is underneath the calculation tab. I'm just going to drop that down, grab the span block, pull it out into my workspace just like this. And you'll notice that there just seems to be a single input. Well, how's this going to work? If I right click this and right down here, expose points for connection. When I select that, I'm just going to go right through and I'm going to grab all of my points. And we're going to just have them here. You can't hit the select all. I just went through and checked them. And just hit the OK button. And this opens up everything that we are going to need for this. And we may not use all of them, but you know, just go ahead and open these up for you just so you have a better understanding. So the first thing that we want to do is, since we're going to be using the outside air temperature, we're going to connect it to our input right here. All right, that is going to be our major determining factor for the output of this particular span block. Now we're just going to go ahead and put some of these in order a little better, our variables, that way we can just kind of take things straight across. Our first connection here, the variable 1, this is going to be our low value, and you can see here input range, output range, clamp highest, clamp lowest, that sort of thing. Variable 1, I'm going to highlight it, and it is going to go to the input range low. I'm going to make my connection here, and you can see the connection is made. This is going to be basically the minimum that it goes to. For example, if we have a 45 degree outside air temperature or 40 degrees or below, This is going to be when our span block is going to be at its maximum output. Now our discharge air temperature high, we're going to connect it to our output low connection. Output range low right here. Alright, and just pull this down a little and make it a little cleaner for us. The next one is going to be our high variable. And what this is going to be is the maximum outside air temperature for the system to calculate low. The higher the temperature, it should go to the minimum. Say if it's 80 degrees outside, you want to have a 55-degree discharge air temperature. That's what this particular one is going to be. And what we're going to do with it is actually connect it to the input range high. So I click here, take it up here, make our connection, and just for cleanness sake, I'm going to move this up a little and pull this one down. That way we can have a little nicer setup here, a little bit better looking screen, as you could say. Now our next and final connection is going to be our output high. This may sound a little strange as far as why I am connecting some of these. Like this one here, it's labeled discharge air temp low, but I'm actually connecting it to a high range output. You can actually get these to calculate plus or negative depending on your connections to these. If you wanted that connection to go the opposite, instead of when the outside air temperature is going down, if you wanted the calculated number to go down, you would then swap those two. So it's a little bit confusing until you actually get into it and see how these span blocks work. And once you do that, it's easy to determine which way you need to go. And I have set these up before and they would be just the exact opposite of what I needed. So I would just basically swap those and would be good to go and back in operation. Here we're just going to make our connection. Just like that. Now our span block is mostly complete. And you can see here I have these 2 points that I did not use. I could go back in and just disable those, but it should be fine. If I go back here to the control block, I need to make my connections. So I'm going to minimize this and bring my connection point up. I'm going to highlight this, and you can see here that we are blank as far as the inputs here. The first one that I need to make a connection to is the outside air temperature. I open this up. Here's my outside air temperature right here. I grab that and I hit OK. That connection is now made. But what about these others? Well, there's a couple of options. You can either set them in the system permanently, or your better option is going to be to add these to the system. You want to have that to where you can manipulate those if necessary. And what I'm going to do here, floating inputs, I'm actually going to grab a total of 4 of them to fill these 4 in here. And simply arrow up, or you can type, hit finish, and you can see that it will create these 4 network floating inputs for us. And I'm going to pull this down. Discharge air set point. Here's our inputs. I'm just going to click these, change the names of them. Just go right here, delete this out, call it DAT high. And if I wanted to put a value in here, default value, let's go ahead and put it at 85. Okay, just the number we're going to throw out there. I'm going to hit save or hit apply and then close this window. Go to my next one and double click it. Same process. Highlight, delete this out. I'm going to call it DAT low. And again, I'm going to put a value of 55 in here. That's the minimum value that I want this to go to. Hit OK, or apply, and then close this window. Moving on, go down to the last two, and we can change the name of these also. Just change it to variable 1, variable 2, but just for time's sake, I'm just going to leave these two like they are. Now let's go ahead and change them. It just take a second. I need to put some values in them also, and that way it'll just save a little bit of time. Variable 1, and for this particular variable, what we want in it, and these numbers you're going to have to play with because every building is a little bit different, and you need to really know how your building is going to perform. For this particular variable, I'm going to put a value of 40 in. The reason that I put that in, if I type it in the right place, is just basically because of one of the buildings that we have. This is one of the variable values for that particular building. And once I enter that, I'm going to hit OK. But what this is, that 40 value, when our span block, the input on our outside air temperature to that span block is 40 degrees or below, that's when that output is going to be at its maximum. All right, now we go on down, we grab our next one, our input, floating input. This is going to be our variable 2. Clear this out. VAR2, and again I'm going to put a value in this. This particular value is going to be 60, and the reason for that is one of the buildings that we have, that is the value that it uses. And these two numbers are going to be very important in calculating the rate of your discharge air temperature set point changes. If at 60 degrees or above, what that span block is going to do, at 60 degrees or above, we're going to be at the minimum 55 degree discharge. At the below 40, we're going to be at the maximum of 85, and in between it's going to float. Now that we have that done, we're simply going to go back here to our discharge output set point. Now then that we've got that made, what we're going to do here is make our connections. I'm going to right click on DAT high, select make a connection. I'm going to scroll down to the bottom where my network inputs are, and this is going to be our discharge air temperature high. Highlight that. I'm going to hit OK. I'm going to go down to the next one. Once it populates that, I'm going to right click here, DAT low. Again, come over here, scroll down to the bottom, DAT low. It's right here. Grab it, hit OK. Now my variable 1, if you remember, that is the one that we set as our bottom number. So I'm going to again right click, drag this down. That variable 1 is going to be my variable 1 here, which is going to be the 40, and hit OK. That makes that connection. Variable 2, make connection, scroll over, come down, hit variable 2. And these points will be pulled into the system. If I wanted to pull them in, you can double click this, go in here, and you can see that it is backnet exposed. So you can pull those into Metasys, and that way you could see those variables and you can manipulate them for your particular building. I would highly recommend that you do that. Now let's go back in here and let's look at this again. We're going to view our logic and see what's going on here. All right, I'm just going to maximize this, and when our outside air temperature is high, these are going to be calculating. To give you a little better understanding about how this span block works, here is one which we have done in LCT. This is an older system. This is actually running an air handler that is controlled by a DX9100, so we did this in LCT. And you can see our outside air temperature currently You can see our variable low. You can see our output, of course, being 55 degrees, which is the minimum here. Now, just as an example, I'm going to take this outside air temperature out of service just for a split second, and I'm going to drive it down to 50 degrees. And I want you to notice how that this will calculate. Since I drive that to 50 degrees, it's still above our variable low, but it is below our variable high, and it'll take it just a minute before, well, I've done something wrong. Let's try that again. Operator override. I hit one too many numbers. So let's try that again. I hit that 50 degrees here, and it's going to make this span block calculate a different value. You can see here we have now gone to 61.5. That is still below the variable high, and it is above the variable low. But once we take that below the lower value, I'm going to take it down to 30. If we had a 30 degree outside air temperature, hit send, you can see that the span block will then go to the maximum outside air temperature. For whatever reason, the system's wanting to be just a little slow, so bear with me. Let's try it one more time. 30, hit send. There we go, 30 degrees there. That span block will then go to the maximum that it is set to calculate to, which is 68 for this particular unit. And now you can see that it is below our variable low. And again, if you needed this number to go opposite, say if it's a different type of application, the span block is a useful tool. You just need to arrange your inputs correctly, the values for those inputs, and you can make the span block do whatever you need it to do. That's basically what we've done here inside CCT, and just letting the system calculate directly from the FEC controller instead of having to do it in LCT like we did in the other system here like this. Instead of having to do it all in LCT, it's better to keep it down into the controller level whenever possible. Anyways guys, this is just a basic video that shows you how to do a calculated discharge air temperature set point based upon outside air temperature. And as I'd mentioned before, you can do this based upon VAV box load. Guys, hope you liked the video. Drop any questions that you have down below in the comments. I'll try to answer as many of them as I can. Be sure to subscribe if you're new here. Check out all the links down below. I've got links to a lot of the tools that I use daily. And I know if you're into this kind of work, there are probably some things there that will help you, that will make your day just a little bit easier. Anyways guys, thanks for watching, and we will see you next time. Check out all the rest of the videos.